let's jump right into it here. Yeah, quick intro is
Yeah, so I'm currently working at a place. We are a data storage company, like enterprise data storage.
right on. Okay. Um, so is there any specific topic that you are prepared for or you're not prepared for? Maybe what companies you have interview coming up or anything like that?
Well, my next interview is with Amazon on
Okay.
Wednesday.
Right on then. So cool. Amazon on Wednesday. That's great. And then so let's see. Do you know what level you're going to be interviewing for?
It's either one or two, like the first of the entry level or the level after. I'm not. Maybe it's three or four. I'm not completely sure of all the level terminology, but it's. I
Okay.
mean, the question is whether I can A, get the job, and B, get the next level. Because I
Right,
mean, I'm
right.
currently at level one.
Gotcha. Okay. Awesome. Um, cool. All right. So let's go ahead. Well, so have you done any practice on the leadership principle questions?
I've answered some questions, but I'd like to just try one just to show what I know so
Okay.
far.
Cool. So, yeah, so we can, let's see, how do I do this? Yeah, that I would say is like a separate thing that to do. And okay, so and then one more thing is did your recruiter let you know if you have leadership principle questions for this phone interview, or is it just technical?
I haven't heard completely. I'm not completely sure, but I think technical. I'm definitely sure there's technical, and I
Mhm.
assume there's going to be both. But
Okay. Yeah, I don't know if you know like the Amazon process, but they're very heavy into the leadership principle questions. So if and when you
yes,
get to your virtual onsite, 4 or 5 interviews, every single one of them will have a leadership principle questions, regardless if it's technical or not.
I
So
mean,
they place a very heavy emphasis on that.
yeah,
Yeah.
I flunked their on-site before, probably just because of leadership principles. Even if I
Oh,
did
okay.
okay in the technical.
Okay. So, right. So I think you probably understand then like how important that is, right?
I do,
Um
yes,
yeah. So yeah,
yes,
if you want, like I would say we could probably save that either for like another mock, like a different mock,
yeah,
and focus on, this one specifically, technical.
yeah.
And I can go do another one with you for the yeah, the leadership principles.
Let's do a technical today, and I guess.
Perfect. Okay. Cool. So, so I have this problem here. Essentially, the binary tree, and basically, I want you to find me the grandparents of the leaves, right? So the leaves here are 1, 15, and 5, right? I think you're aware of that, right?
Yeah, I've heard of that before.
Okay, cool. So in this case, the grandparents for this would be 3, 3, and 20, right? Because the grandparent of 1 would be 3, 15, grandparent of 15 would be 3, and then grandparent of 5 would be 20, right? So this would be the output for this solution here for this
Yeah,
problem.
I see.
Okay.
So I think the first thing with this, oh yeah, so you can repeat the same value twice, I guess. I just want to
Yes,
clarify
that's
that.
correct. Yep, that's right.
Yeah. So no need to have like some set data type
Right.
here.
Hmm.
Yeah.
Yeah.
So the other thing that I just want to confirm is that like actually I don't think I have really anything else. I think what I'm going to end up doing here is a recursive algorithm, and I'm going to have a function that returns 0 if it's the base case is return 0 if it's a leaf, and return the number of the distance from the leaf if it's in each direction, actually, because
Hmm.
we have to figure out if any of them is equal to 2, if either the right or the left has anything equal to 2, and if it's greater than 2, we can ignore it. So first we need to like define a tree class.
Okay.
So we can say class the Interesting. It's good that you're already choosing Python. That was my choice in the first place.
Oh, sorry.
It's fine.
Yeah,
It's fine.
I was expecting that you chose your language already. But
Yeah. Oh yeah, but it's fine. Yeah. Init, and then we can say value, actually self, and we can say self dot. But actually, there's actually an interesting thing we can do here, and that is we can use a bit of the heap implementation for this. That will take that'll take a bit more space. So yeah, I think I'm going to continue with the normal tree class implementation.
okay.
I was thinking of like just making an array and making it into a heap, but the problem is that we don't know if the tree is balanced or not. Like you could have like one very long branch and nothing else, and that would take up a lot of space. So that's why I'm not doing it.
Mhm.
So we can say def and actually I'm just going to put it here, and then we can say t just for any tree. So we can say that if t dot left is equal to none and t dot right is equal to none, actually this is a helper function that we need to call. Actually, I think I'm going to switch. Actually, I'm going to use the heap implementation. It's going to be easier. So
Okay. How about you don't delete that? Just
okay.
leave it,
Okay.
comment it out or something,
Yeah,
and
but
then yeah. It's, I mean, I think you can like select the whole thing and control. Can you not?
yeah. So the reason I'm going to go with the heap implementation is that it's very easy to find the parent and grandparent. And we can just find all the leaf nodes.
Okay.
So what we can do here is that we can say that that def leaves. So we just need to find the leaves of a tree,
Okay.
and that's going to be if so now we're going to provide I for the node in the tree we're at. So if I is equal to is greater than or equal to 2 times I is greater than or equal to len of t, then we can say, and so here t is a list, which represents the tree in kind of the heap format. So do you know what I'm talking about by saying like heap format here?
You can give an example of that. Maybe it's a
Okay.
little bit more clear. Yeah.
Yeah, sorry, I wasn't so clear about that. So I'm gonna put this in heap format. 9,
Okay.
20, and then 9 times 2. Yeah, so actually I'm gonna put 0 at the beginning, just actually -1, just as a dummy.
Mm-hmm.
So the idea here is that the children of any node are equal to 2n and 2n plus 1.
Okay.
So 2 times 1 is equal to 3, 2 times 1 plus 2 times 1 is equal to 2, 2 times 1 plus 1 is equal to 3. Then 1 is going to be 2 times 2 is 4, and then this is going to be minus 1, just meaning a dummy value.
Mm-hmm.
We can just have any dummy value. We can actually make this equal to none to make it, because we could have negative numbers in this. And then 2 times 20 is going to, this is going to be 15, because 3, and this is 6, and then 7. And then we have to have like a 9, 5. Yeah.
Sure. Okay. So are you expecting this as an input, or are you going to build this?
This is going to be built, but I'm going to show you what the quick way to solve it from this.
Sure. Okay.
And if 2 times I is greater than length t, return I. So this is if it's not a leaf, then we're going to recursively call on the left and the right tree.
Okay.
So we can say that and actually there are a couple more cases here, because we have to figure out if the left and the right tree are both equal to none. Because if they're both none, then it's a leaf as well. Or 2 times I t, 2 times I is equal to none, and put these in parentheses just to be sure about this. So this is the base case we have here. This is just trying to figure out if something's a leaf.
Okay.
And this is the main case. So we can say that if we have a couple if statements to do, if then we can say that result is equal to t2I. And similarly, actually plus 1. And similarly, we have the other case where we have plus 1. So these are the cases where we have just one child of a node.
Okay.
And we have one more case where both of them have children, so we can say else. And we're going to append the results of both of these. We're going to concatenate the results of both of these. So after this, we get and then so I want to test this one function just to make sure it does what we expect it to do. Because
Sure.
after this function, we just have to do an operation where we do integer division on this 2 times.
Okay.
And in fact, we can just do division by 4, I think. And this should work. So I'm just going to do leave in this tree and say, yeah, nobody's arrested.
Sorry, can you like maybe walk through the example instead of maybe running the code? Can you hear me?
Okay, yeah. So instead, what we can do is that. So we're gonna make leaves of 1. So for the first one, we get 3, and then 2 times, and then 2 times 1. So 2 times 1 is not less than that, and neither is one T2 and T3, which are the 2 things that we're calculating here. So it's not the base case. So at this point, what we do is that we say that neither of these is none, so we have results is equal to the null string, and then we make a recursive call on 2, and that will go to the else statement, but it will go to the elif t of 2 times 5 is equal to none, because the test 5 is equal to none.
Mm-hmm.
And then it will return leaves of 4, which is the one. I'm going to highlight it right here in test.
Mm-hmm.
And then since both of the 2 times 4 is 8, and 8 and 9, test 8 and 9 are equal to none, then it returns it just returns 4. Yeah. So do you want me to show the other calls that it makes?
Sure. So sorry, you said at 5 it returns 1. So this is just to get the leaves.
Yeah, this is just to get the leaves. Yeah.
Okay.
It returned a list of
Gotcha.
leaves. Because once we get the leaves, we can just say that I'm just going to define a function for def. So now I can answer the question here of where L is a list of leaves. I can make this variable name a bit easier. So we can say results is equal to for leaf and leaves if so this is the function we're using to get the leaves of a tree. The grandparents of the leaves, because we're given a list of leaves, and from that list of leaves, what we do is that we will divide everything by 4, integer division.
Okay.
Because dividing by 4 will go up 2 levels.
Cool. Okay.
So do you want me to actually run this code, or is that that doesn't matter?
Doesn't really matter. You can try running it, see if it works. If it doesn't work, don't sweat it. We can move to the next part.
Why is it not?
Oh, you're probably because you're missing a end bracket at the for your test. Your function. Oh, what the hell just happened?
Oh, yeah.
Yeah, but why is it all commented out?
Because I changed the programming language a couple times.
Oh, okay. I think you can I think you can do this. Does it not work?
I'm not sure if the shortcut.
Shortcut doesn't work. Okay. Yeah, that's unfortunate. What language did you change it to?
Just Python 3. I was just
Does it matter?
I don't think it matters, but I was just curious. I can just delete all of this. Let me just delete this. Actually, I'm including a lot of stuff that that's a good catch, though.
Sorry, so what's
that there was an end bracket that was missing.
okay? So why are you commenting out the tree class? What's
Because
going on here?
this is not the code that I was using. I said I was
Oh,
using.
okay.
Okay, let's run this. 4, 6, 7. Okay, actually, there is a mistake here. So, actually, yeah, no, this is not a. There's a mistake in this that I need to think about. That I have to actually append. And there's one other thing that has to be called. We have to have a function that calls both of these sequentially. So we have that. I'll just make this. I'm just shortening everything.
Okay. So when you give it the one is like that's the root, right?
That is just yes, the root, yes.
Okay.
So we can say that's the root, yes. It takes exactly one argument, yes, so it's going to be test 115. Oh yeah, 115. Oh wait, this is not right. I'm going to debug this quickly because some of the interviews I have done, I need to debug this. Like,
okay, okay.
leaves test 1. 4, 6, 1, 4, 6, 7. Four. So 6 over 4 is not equal to. So 1 is correct. 15 is correct. Okay, so grandparents. So I think the grandparents function is faulty. This
But
is
aren't you
7.
calling the function leaves and
Yeah.
it's not giving you the right leaves?
Yeah, it should be 4,
So why would you think it's the grandparents function?
because I think there's an error with that as well.
Okay. Well, I mean, your first function is not already wrong, right?
Yeah, so 7 times. But actually, the formation of this is wrong.
Okay.
And the problem here is that this should be 1, 2, 3, 4, 5, 6, 7, 8. There should be 7 nuns. And now we run it again, and yes, 15, which is going to be 5. So it works now. The problem is that I just didn't. The construction of the string was not right.
So it's 4, 6, and 15.
Yes, because 1, 2, 3, 4, 5.
Oh, you're
6,
returning the
7,
indexes.
8. Yeah, these are the indices. Yes,
I see. Okay. Okay. I see.
and then we
Okay.
can say. Um, so 7 was actually. GP takes exactly 1 argument. Yeah. So. Tree. So there's an error of this. I'm going to check that.
Okay.
Okay. Because it's not dividing all of the. Oh, this is what I'm missing. And this is what we want. 320.
Gotcha.
So the thing that I was missing is just that I had to append a tree of leaf divided by 4 integer division.
Okay. 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 Cool. So, maybe one more quick question here is right now I've given you asked you to find me the great grandparents, right? So if I wanted to give you an integer n, let's say, and I want you to find me the grand nth parents, right? So if n was equal to 2, you would give me the grandparents.
Yeah.
If n is equal to 1, you would give me parents, right? And so on and so forth. How would you implement that?
So that's a very easy implementation from here, because
Okay.
all we need to do is just change this value and add a value n here, and then we can add n here, and then n, and then 2 to the n.
Okay.
So if we make this equal to 2, then it's going to be the same. 3, 3, 20.
Okay.
If you want to make it into 3, then we'll only have 3 because 2 of them is going to bounds, which
Right.
is exactly what we get.
Cool. Okay. And then what about if it's equal to 1?
Equal to 1, what?
If
Oh.
if n is equal to 1.
I can do that right now.
Uh-huh.
927.
Cool.
Which is correct.
Okay. Right on. So yeah, okay. What is the time and space complexity for this?
So the one kind of caveat with the space complexity is that if you do not have a balanced tree, then you need 2 to the n space complexity. But the problem is that is an asymptotic worst case, and not an average case.
Okay.
But for time complexity, you just need to, like, assuming a balanced tree, you just have O of it and time to find the list of grandchildren, of all the leaves, I mean. And from that, you just have O n time to find the grandparents or any level.
Okay. Cool. So your test here, you're actually using the array definition, array representation of the tree, right?
Yeah,
Did you say that you were going to write a function to do that kind of conversion, or
I can do
are
that.
you expecting that? Okay,
I can make that function myself.
sure.
So
Okay.
I'm gonna make a class. I did this because it's easy to do the quick division by
Uh-huh.
2. But I
Okay.
could also make an implementation where I have a function. I have a property parent for every leaf, but that's not a common implementation. So like
Okay.
that takes a
And
bit of
why is that?
time. The thing is that I'm assuming a normal tree. So I'm gonna make a function to convert a normal tree into a this format.
Okay.
Would you like that, or do you want me to make a
Sure.
function to convert the other function? Okay,
Yeah.
I can make a
Let's go ahead
class
and do
where
that.
I have def self. So this is just a quick definition. So using this definition of tree, we can say def. So we have the we're gonna use a helper function obviously for this because we need to edit an array that's from multiple layers of recursion. So we have to use a helper function. So we can say that results is equal to none times 2 to the t. So I'm just initializing everything too. I'm actually going to use a for loop to initialize because there are sometimes problems with this approach, the multiplication operator. It's just something I've figured out.
Okay.
Range to. Actually, we need to find the maximum depth because t is not the right format. So we can just say that so what we're going to do is just define. We're going to have to define a function to expand the array.
Mhm.
Actually, there's a quicker way of doing this. I'm going to use a hash map because things could get messy.
Okay.
And I'm going to hold a maximum value. So we can say like max index is equal to -1, just saying nothing is done. Then we're going to have hash is equal to, and then we can have, and now we're going to call the helper function. I'm going to define a helper function, which is, and the helper will add to the hash for every value it finds. And actually, we have to have like I. And so I is going to store what value we're going to assign to it. So we can say that if t, so we're going to assign hash I is equal to t dot value. So at this level, we're going to just assign the top value, and then we say that if t dot left not equal to none, helper t dot left 2 times I. So basically, we're going to use 2 times the value that basically getting to the left index. And we're going to do the same thing for t dot right, except 2i plus 1 not equals to none. Helper t dot right 2 times I plus 1. So I've done both the left and the right child. So this doesn't even need a return value because we're just modifying the hash.
Mhm.
And we can also say that, and now we call this function on. So I'm calling on the first index. So after this, we need to convert the hash into an array. But we're going to keep into account the max index, so we can say that if I this is just to keep track of the max index. So we can say that for I in plus 1, I'm just trying to define an array that's longer than that. So we can say although I want to say that we don't even need to do that. We don't even need to make this second tree because I mean, yes, we can do this and just return. But I want to actually say that there's a more optimal way of doing it because we can make the whole thing into hashes. But we'll have to figure out, instead of whether it's equal to none, we have to figure out whether the value exists in the first place.
Mhm.
Because we
Okay.
don't even need to have to store all the values, like to the
Okay.
n values. So I want to actually make an improvement to the whole function in general because of this, because of what I've seen here.
Okay, that's fine. I think I know where you're going with this, so I think that's fine. This is okay for now.
Yeah.
Cool. So yeah, I think this is good. Let's take some time for the feedback, right, for this problem here.
Yeah.
So overall, I'm impressed that you went with this kinds of solution here. This is, I actually have not seen anyone do use this approach. I would say this approach is probably, you can probably use this approach for maybe some more difficult kinds of tree questions. But in the end, this question is not like a very difficult one, right? Because you're technically just, finding the leaves and then finding the two, parents from that. So in the end, like if you go like just a normal tree function, tree class, and traverse it to find the leaves and stuff, it's not a very difficult solution. So it's surprising to me that you are using this kinds of solution. It worked, which is fine, but I can see how this solution is quite complex, and if you do, make a mistake or something like that, it's like kind of difficult for you to debug or something like that, right? So it works. It's just like a very much more complicated, solution for a problem like this, right? Where it's like not quite necessary.
You know why I do stuff like this? Because I've had bad experiences with not finishing tree questions in time on interviews.
And why is that?
I think one of the problems is that actually, like, one of the difficulties is finding the parent of a node, because
Okay.
like I don't want to even have to deal with implementation, because one thing I really like about the implementation of trees is that you can easily find parents.
Okay.
There's
So
no, there's no problem with that.
what's so hard about finding a parent using the regular method? What
So
how would you do that? I guess. Yeah. What would your difficulty be then there?
so are you suggesting like I have like an extra
Well, I'm asking you, right? Like,
yeah,
I didn't give you any definition of what a tree is.
yeah,
I just tell you that this is, what the tree structure looks like. It's up to you to make whatever class you want out of it.
yeah.
But I'm curious to know why you think that, it's hard to find the parent. Like, what strategies are you using, and what makes it hard for you?
So I think what you were expecting me to find is that I would make a recursive function and get to the last values, and then store a pointer that is actually store like a return value that says that returns 0. Like, so if it's the bottom level, I return 0, and then if it's any level above that, I return. Actually,
Well,
no,
no. My question was just like, why do you think that in the tree question, why is it hard to find the parent? Or, what strategy are you currently using to find the parent, which it seems like to you makes it hard?
that's. I think the thing is that I've sometimes tried to make a pointer and that doesn't work. Just add an extra value in the tree that says like self.parent is equal to parent.
Okay.
That's not
What's wrong
good.
with that? Like, when you say not good, as in like people don't like that, or what do you mean
It's
by that? Right.
I
Uh-huh.
think it's somewhat slow to code.
But you just made a one-line code change. How is that slow to code?
It's slow to actually build a tree that way.
Okay. Maybe I'm not quite understanding why that's difficult. If you make a one value code
Yeah.
change, as you're traversing the tree, you just save the parents. I'm still
Yeah.
trying to understand like why you think that makes it difficult, I guess,
I don't know.
and why that's hard.
I think
Because that is like the easiest solution
yeah.
is to assume that, hey, let's just assume that the tree does have the parent, or you can populate the parent as you traverse the tree. It's actually like, as you traverse the tree, you just populate the parent, right? So, I
Yeah.
mean, I'm trying to understand like why you think it's
Yeah.
hard, and like what's deterring you from
But
using this kind of strategy.
but that's actually a good thing to mention today, because like it's because I think in some ways, I think that just reviewing the whole situation with hashes, like it really drove home how elegant the hash solution is.
Well, so there's another solution to this, right? That will work is if you create a child to parent mapping,
Yeah.
right? So you know what that is, right?
Yes. Oh, you have like a dictionary.
Yeah, you just have a dictionary, and you would have the child references to the key is the child, and the value would be the parent, right?
Yeah.
So that's one way. Another way that you could do this, right, is that, right? So that's also a very simple solution, right, to get the parent.
Yeah. But actually, I think it's partially a bit of just a bit of trauma with tree questions, because on because I've had 2 questions that I couldn't finish in time because I had some bug that I got the logic completely right, but I had some bug and I got rejected twice.
Interesting.
So like so I think
Okay.
it's a reaction to that I'm
Okay.
trying to
Maybe
trying
like,
a
yeah,
different approach.
I would say that your approach here is much more complicated and much more prone to error, right? Because if you're trying to debug this, there's a lot of math here, right?
Yeah.
And it's a lot more difficult for you to be like, oh, 2 times
Yeah.
2 plus 1, whatever is like this, whatever index. Like, to me, this is a lot more difficult of a question, and a lot more difficult solution, and not as many people would quote unquote understand. I mean, I think they would know, like, I know what this is, I know what you're trying to do, and I know what this kind of solution is, but it's a very unorthodox, solution,
Yeah.
which if people are not as many people are familiar with this type of solution compared to a normal tree solution,
Yeah.
right? Then they are more on the side of like, oh, they need to like fully understand like what you're trying to do, and it can be a little bit more difficult to communicate to them, right?
Yes.
So that's just like my tip there. And like, like I said, your solution here works, and you've proved it to me by even running the code, right? Which is, great that you're able to actually debug this very quickly, right? So that shows that you do have that good debugging skill. The only worry that I have is if and when you do find something that you don't get it to work, or they don't ask you to do the code and just accept it, that's fine too. But if there is some sort of bug here, it can be a little bit difficult, right? And difficult to understand. Like, so that's just like a main thing, right? So I would say you may not want to be so deterred away from the original kind of tree questions. Maybe you should look at, okay, what made those questions that you failed hard, or what made those difficult for you to finish, right? And maybe that's something that you could work on, and maybe get better so that you don't have to result to like a much harder kind of solution here.
I want to actually say I don't think this is actually harder to debug, because I think it's much easier to be able to print out these arrays. Just print out them. Because that's the reason I like this, because I can print it out all at once and just understand what went wrong.
Okay.
For an actual tree, like I can't just print out the whole tree at once easily.
Right.
I think that's what I'm getting at here.
Gotcha. Okay. Yeah, no, that makes sense. Right. And I'm not sure, which companies you have interviewed for, but I don't know how many of them have kind of like asked you to run the code, right? A lot of times they don't ask you to run the code. From my experience, I have had companies that have run the code. Like I interviewed at Zillow, they asked me to run the code, write test cases and stuff. But there are times where they don't really need you to, right? They just want you to maybe write some test cases and stuff like that. So, I wouldn't also rely on the fact that you can run the code to debug your stuff, right? Because like, for example, at Amazon or at Google, like some places they have like something like this, but you actually can't run the code. It's actually just like a notepad.
And that's why, and that's actually another good reason to specifically do the tree solution, or just store a parent.
Yeah.
Because I've had 2 bad experiences with having to specifically run the code for trees. And it's cost me a lot.
And how's that? Like, what do you mean by that? Like, do they force you to create the tree and then
they force you to they create the tree for you, or they create something that you use to create the tree, because not all of these questions actually have you create the tree that actually have, like, it started with the data. Like one of the questions, actually, you were supposed to create the tree from a list of mappings.
Okay.
So I didn't have the tree at the beginning, but it was easy. But the code was to create the tree, and then
I see,
find a random value from it. And I had everything done except I had some bugs at the end and couldn't finish in time.
Okay, cool. Yeah, I mean, I think it's good to know both ways, right? And then you can assess, which way is better for you, right? That's fine. But yeah, like I think, I think for this kind of problem, it's quite easy to do using the other method, right? So, and there's an iterative method and recursive, right? So depending on which one you like to use, or whichever one, in my opinion, I think the iterative method is a lot easier to understand and see, all right, and to debug compared to like a recursive function, right? So I always do trees using the iterative method, right? Using either a queue or stack. So yeah, maybe that's something that you can look into if it's easier for you to do that.
Interesting.
Or not.
Use a queue or stack for trees, really.
Yeah. So let me. I can give you an example here, right? So like so I just pasted my solution at the very bottom here.
Yeah.
Right at the very, very bottom, if you go, can you see? Yeah. So this is like a find n parents up the tree. This is having the roots here. and basically you add. This one is I'm using a parent to parent mapping. So like unlike whether a parent mapping, or you can use the parent map or whatever, right?
That's
So
actually
up to you.
that's a very good idea, actually. Like, this is very elegant. Is this specifically your code, or is this specifically code that
This is specifically
staff
my
code?
code.
Okay.
This is specifically my code, right? And I use the same strategy for all trees, which is to use a stack or a queue.
Yeah.
So a stack is for
Yes,
I think it's a
understand this.
BFS, right? So I think it's a very easy way to debug, right? And it's like a lot easier to understand like how it's what's going on. Yeah. So yeah, I mean you can take a look at this if you want. And I think the good thing is like having multiple solutions, like different types of ways to solve the problem, a tree problem, right, is a great way to keep in the back of your mind, or like as a tool belt there. So
I think, another thing that I somewhat struggle with is just skills explaining while I'm thinking of a solution, because I think it's sometimes difficult for me to talk and think at the same time, because I worry about like sounding stupid if I just talk and think at the same time.
It's definitely not like a very intuitive thing to do. And I can see like you're actually I can see that you're trying very hard to do that, right? It's like, okay, you're thinking, and then try to think about how to explain this. So it takes some practice, and it's not for everyone, but like with some practice, I think it gets a little bit better. Another way that you can try to do this or communicate is like you can ask you let the interviewer know, it's like, okay, or give me a minute or two to think about this, and then I can explain to you what I'm thinking, right? So maybe give you some time to think about what you're doing, and then maybe give you some time to then articulate, okay, what are your thoughts, right? I think the main key thing is to really keep your interviewer on the same page. So the issue is when you don't talk or you don't communicate for some amount of time, then they don't know what's going on. So if you just let them know that, hey, I'm thinking, or give me a second to think about this, then they're actually like at least know what you know what to expect, right?
I mean, why I think I failed this last interview that really hurt me? Like, I think that when I was trying to debug a function, I kind of got somewhat frustrated because the guy went to the door and distracted me. He just wanted the keys to the laundry room, but he came to the door, distracted me, and then I had to kind of debug a function, and I was somewhat stressed and frustrated, and that was showing.
That will happen. That will happen for sure, and it's unfortunate. But
that's why I'm here, because I don't want to have another interview like that. And
unfortunately, there's not much you can do about how other people perform. So you can only worry about how you do. So
I'm gonna put a sign on my door next time. Do not, if I'm like actually consider making legal penalties if someone actually does that, because it could be costing money.
Yeah, exactly.
Like actually threaten a lawsuit if they knock on the door all the time.
Interesting. Yeah, that's right. Cool. So in the Zoom chat here, I'll send you my LinkedIn. Feel free to connect with me if you want to do, I don't know, another session or something with the leadership principles, because I feel like it seems like that the leadership principles is kind of where it's like very important, and something that you may need to work on. Then I think that's great, right?
I think actually something that maybe I'm not doing right is that I haven't really worked too much on having a LinkedIn profile. I have some kind of a very I have kind of a profile I've made a very small amount on, but I think I've mostly just made a resume and sent it to people, and I haven't really, maybe I haven't done that enough. But I've gotten some interviews, but like, I'm not sure.
That's great. Yeah, I mean, getting interviews is great. I think having a LinkedIn is like, because everything is digital now. Every like recruiter is hiring through LinkedIn, so it's very powerful to have LinkedIn and a strong LinkedIn, so that opens up many doors.
I might actually try to have a real profile.
Yeah, I mean, I think it's good to build a network, right? As an engineer, to have referrals or other people and stuff like that, I think it will help in the long term, right? Like
Yeah.
I think pretty much almost every single one of my jobs so far have come from a form of a referral, and referrals make a huge difference. And then that's the kind of embarrassing.
Yeah.
And then a year later, he referred me. I pass the phone interview and I go into the onsite, and I don't do too well on the onsite. So it happened.
I think I'm just trying to seek out referrals for some companies I might not know people for, and that's maybe what I need to do.
Sorry, what?
I think I'm trying to seek out referrals for companies that I might not know someone for a priori.
Right. Yeah. You definitely want to build like a good connection as well, because then they can actually have something to kind of back you up, right? In a way.
Yeah.
Yeah.
I mean,
Cool.
I feel like,
and by the way, the fact that you may not have as much experience, right? Like, it's okay, because even though they've seen that, hey, you've only had like one, I think it was like 1 or 2 years out of
1.5.
college. Yeah. So like they're not going to expect like you have that much experience, right? But that's not a limiting factor on how you can present your examples well, right? So like it's all about how you present your examples, how you can tie it back into like what type of person you are, with your work. So like that's not a limitation. That's all I'm saying. You can try to come up with a lot of examples.
I have a pretty large project that I didn't make the initial deadline for. I can use that for a couple of them. And I also, in college, I had someone who I had a project partner who really was struggling in the course, and that might be another one as well, because I spent a lot of time trying to help him, and like specifically, like I think I might have helped his knowledge in the class, but eventually I was forced to do the project on my own because the deadline was fast approaching. But I think I would have presented it differently in an actual interview.
Right.
Because I was just trying to briefly cover some things that I am planning on using as examples. And another question I'm prepared for is like, think of a time when you caught a bug or something like that. Or you like help. I don't think it's exactly that, but it's something similar.
Yeah, I think like developing a good number of examples is great. Yeah. So if you want to do like so your interview is on Wednesday, right?
Yeah.
You won't even have to do the phone interview at Google. You go straight to the onsite.
Really?
Yeah, if you're from a FANG, right? So, and Amazon is the easiest FANG to get into. So
I can see, but the problem is that they're so intense on behavioral questions, and to be honest, those are the ones that kind of scare me the most.
Yeah.
So
I mean, that's a great thing that you acknowledge or like you realize that, right? So if that's something that you feel like is weak on your part, then I think you can double down on that, right? So
I mean, if I gave a solution like this, would I pass at Amazon, like just from technical?
I think this would pass. Yeah, it's a little unorthodox, but it would pass, and because you completed the problem, you came up with an optimization and stuff. So a little bit more about kind of like the overall flow of the interview, right? That I totally forgot to finish is you came up with a solution, right? Which is good, and ideally you kind of want to like explain it a little bit more in depth before you go straight to the coding, because the issue is like if you go down the wrong path, it can really cost you, right? Like the interview. So you want to make sure like, okay, this is the solution you want to go towards, and it's like the right basically what the interview is looking for before you code. Otherwise you midway code and then you realize, hey, this is not what they want, then you've like wasted half your time. So the communicating aspect is really, really important there.
Yeah. So how much do you lose for getting very close to a solution but not completely finishing everything?
It really depends on the guideline and the type of problem. So a lot of the times like they want to make sure that like you're at least you have like the framework of what you're wanting to go towards, and then if you have like a bug or something, then they'll probably overlook that. Maybe like, okay, that's still okay, they had a bug, that's fine, right? But if it's like you're halfway through the solution, and you know what you're doing, then it's more about identifying like, okay, why were you only halfway through the solution? Is it because you spent too much time thinking about it? Is it because your coding isn't strong enough, right? Because those all play a part.
I mean, but do you think when I have an interview where I get very close to the solution, I'm just a bug away? Do you think it's a behavioral thing? I mean, there's not specifically a behavioral question, but do you think it's a behavioral thing?
So now you have to think about, okay, what could you have done in your interview that maybe would have prevented you from making that bug, right?
But do you think it was because of the bug or because of my somewhat maybe displaying like too much anxiety or frustration when I missed a question? When I was struggling to fix a bug. That's the real question. Like, do you think it was the bug itself or my somewhat reaction to it? My reaction to it. Like, was it the bug itself, or like, did I just react wrong and lose the job that way?
Now you have to, if you acknowledge that, okay, you're like one bug away and maybe it's anxiety or something like that, then you think about, okay, within this interview, is there something that you can do to maybe prevent your bug? Like, is there something that you could have done to prevent you from making such a mistake? If you had taken a little bit more time to go over the solution, to go over your algorithm, would you think that would have helped you, not cause that bug, right?
You
So
know what I
that's
think I think what happened that actually caused the bug.
Huh.
A type error with sets and
Okay.
lists and dicks.
Right. Okay.
And
Okay, that's fine.
And actually, one of the things that's good about doing all these practice questions is that I'm able to practice those data structures a lot and make sure that
Right.
I get the right answer for
Get the reps in, right? And do more practice. If you have more practice, you're gonna mess up less, right? Like, so practice makes perfect.
and also
So,
like I can be faster on stuff like random stuff, like random at choice. I know that now. I used to not know that. Also,
right,
stuff
good.
like just some other stuff like.
hmm So let's talk about like the overall interview, like not the process, but like the flow of the interview, right?
Yeah.
So you want to get the flow of the interview kind of like down to the T so that you don't miss anything. For example, right, in this interview, I think something that you could have done. So it's like a checklist, right,
Yeah.
of the things that you need to do, right? So for every interview, right, you need to come up with your own examples, right? In this case, you didn't really come up with your own examples. You didn't really talk through maybe some of the edge cases, even though your code kind of handled them. You didn't really talk about all of them, right? So, for example, if you go to the very top here, I'm highlighting the example. A better, like, something that you could have said in the very beginning was, okay, well, what if like this one was not here, right? Then 9 here doesn't have a grandparent. What would my output be? Something like that, right?
I
So,
kind of assume that the tree would be well formed. That was maybe an oversight.
right. Yeah, exactly. So these are some things that will also help identify, and help with your communication, right? Is to so like I said, the first tip that the thing that you need to do there is come up with your own example,
Yeah, just ask if it's well
right?
defined first and
No, not even that, right? It's more of just come up with your own example. Be like, okay, what if the tree is this, or what if it's this, right? Like, think now it's like you have to, like, a lot of times people think, oh, you can think of the edge case at the end. Try thinking of them at the very beginning, because that will kind of maybe help shape your thought process, or help shape some things that you maybe oversaw, or maybe help think through a bug that you would have missed at the very end, where it took you more time to figure out versus if you thought about them very beginning, right? So all these little things that can help you expedite your solution.
So do you think that like how much? So what if so like about follow up questions? Like how important is it to get all the follow up questions correct to pass the interview?
It depends. Depends on how fast you are. Ideally, you do want to come up with the follow up solution, right? So just be on the lookout for that, right? Like, if they do have a follow up solution, for the follow up solutions, there's a little bit more leeway to that, right? Those, if you have the right idea, right, and don't fully code it out, then they're most of the time they're okay with that, right? But as long as you have some sort of like working solution, maybe you have like maybe pseudocode, or just like, okay, some few lines here and there, And then maybe some things that you're missing and you're running out of time, then you can let them know, oh, I just forgot. So all I need to do here is add a visited set or something like that, right? And like something that's very simple to do, but you maybe ran out of time or something like that, then that's acceptable, right? That's good enough.
You had an interesting question where the follow-up was actually extremely trivial given the implementation I had.
Right. And that's a great thing, right? Because the solution you had was like fine. However, a lot of people, when they do this question, they do say a recursive solution, and they don't know how to pass down the parents or whatever, right? So a lot of times what they do is they call the recursive function and pass down the parent and the grandparent of that current node, right?
Oh,
so
yeah.
they'll right. So that's like a very intuitive solution that a lot of people think of, and that is where that solution wouldn't work for the follow-up, right? And then they have to think about, okay, then I can't use this solution to use the recursive solution and just one pass through to find it, right? Because if it's n, I would have to have n inputs, right?
Yeah.
Which one? So then they had to think of like a different like solution. So yeah, that's just a different strategy depending on how you do your solution.
Yeah.
And the reason why you want to talk through the time space complexity once you figure out the algorithm is you want to make sure that this algorithm is the most efficient, right? If it's not, then you want to call that out and make sure that, okay, I know that it's not the most efficient, but we can optimize after this. Is that okay? And this is the key thing, is you want to make sure that the interviewer is on the same page with you. You can't just code up the solution and be like, oh, okay, this is the solution that I'm going to do. And it's not the most efficient, but I'm going to do it anyways. The interviewer may not like that.
I understand that. I know I have to do the best solution, and like, or
it doesn't always have to be though. It does. See, that's the thing, is it doesn't always have to be. You can come up with a not a very efficient solution. It depends on the interviewer. The interviewer may be okay with it, and they're looking to see if you can come up with this solution perfectly fine, and then come up with a optimization, right? So it really depends on the interviewer. So that's my point, is like you really have to communicate and understand your interviewer, right? These are the soft skills that I think are for this interview that really showcased why they select these engineers, because they want to make sure that you can work well within the team, right? If you have a solution, you don't make sure your team's on board, your manager's on board, and then you go do it, you actually waste a lot of time and stuff like that. So
is it likely I'll fail an interview from getting a correct solution but not really discussing it too well before I code?
It can be, right? Because that shows that your communication is not that great, right? And communication is actually a big key in doing this, right? Yes. So it's not an issue. It's not an issue for many people, maybe because they're, they talk pretty well or whatever it is, right? So some people might think it's not a big deal, but to some people, like it's actually a very big deal in terms of like the value that they value at work, right? So yeah, they value the communication pretty well there.
So I really should discuss the whole thing before I even start coding.
Yes. And to help with that, you can write down, and to help with that, right, what you want to do is like write down exactly, try to write down your notes, like keep maybe, so like for example, this case, right, you want to write some, not pseudocode, but just like some key level highlights, right? Find like for example, I'm typing at the very top here.
Actually type this in. Actually type this stuff in.
Yeah. So the other key thing is anything that you type on this sheet here, on this stuff here, it's all evidence, right? Like basically they're gathering data and evidence for your interview. What data points does do? What can they prove to show that, hey, they did this and that? Just because you said it does not mean that they're going to remember it. Like just because you said the time space complexity, I may, for whatever reason, I may have forgotten if you said that or not. Let's just say I did an interview with you. 10 minutes later, I have 2 meetings back to back or whatever, and then I don't have time to finish your interview until tomorrow morning, right? I may not remember every single word you said, right? And that's like my bad. But for you to prevent that from happening, and for you to prevent that, if you write it down, then I won't have an excuse, right? I'll see it in my notes, and I'll see that, hey, he did talk about the interview, the time space, he straight up wrote it down, right? So that's my point, is like writing down whatever comes to mind, whatever is always good evidence for you. So if you go to the very top of this page here, I'm writing, for example, if I were you, I'd be like, okay, first step here is like, I need to find the leaf of each node. I'll find all the leaves. right? And then second step is to go up twice to find a parent or something like that, right? So I don't know if you can see what I'm typing. I'm typing at the very top of the page here, but so yeah, something like this.
Yeah,
Right?
I see.
It's very simple, not very hard, but it's like it keeps you accountable of what you said you're gonna do, and it keeps them to remember. Okay, what did he say he was gonna do?
Yeah.
Well, yeah, I gotta jump off, but it was good talking to you, Adam. And yeah, so you have my email and stuff. So look forward to seeing you schedule that for Monday.
Yeah, Monday. Anyway, thank you for this. This was very helpful.
Cool. All right, I'll talk to you later, man.
All right, bye.
All right, bye.